How enzymes work. We have talked about the kinds of reactions that happen in your body: DNA, protein synthesis, cellular respiration, etc., and how molecules can change. You should know that it does not happen on its own. If you leave a blob of protein in a petri dish, will it just break down into amino acids? No. What will break down the proteins? Enzymes. Enzymes are the biological substance, proteins, that act as catalysts and help complex reactions occur everywhere in life. A catalyst is a substance that increases the rate of a chemical reaction by reducing the amount of energy needed to start the reaction. Remember, catalysts are not just one and done. They work over and over and over. When you go home at night and the door is locked, can it open itself? Nope. You need a key that is just the right shape to fit that lock. Otherwise, you're stuck in the cold. Enzymes work in a similar way. Enzymes complete one very specific job and do nothing else. They are very specific locks, and the compounds they work with, substrates, are very special keys. There are 4 steps in the process of an enzyme working. Number 1, an enzyme and a substrate are in the same area. The substrate is the biological molecule that the enzyme will work on. Number 2, the enzyme grabs onto the substrate with a special area called the active site. It's where the action happens. The active site is a specially shaped area of the enzyme that fits around the substrate. The active site is the keyhole of the lock. 3, a process called catalysis happens. Catalysis is when a substrate is changed. It could be broken down or combined with other molecules to make something new. 4, the enzyme lets go. When the enzyme lets go, it returns to normal, ready to do another reaction. The substrate is no longer the same. The substrate is now called the product. Here's a picture of how enzymes work. You can see that the purple is the enzyme. So the purple is the enzyme. Here's the active site where the action is going to happen. The substrate comes along. It's got to be the right substrate for this enzyme. It has a specific shape. It fits right into the shape here. So it's kind of like this is the lock and this is the key. When it comes in, it's the enzyme substrate complex. The enzyme will change it. This is now the product, and then it is going to release the product. Enzymes sometimes need to be controlled. Other times they are controlled because of poisons and contaminants. So what affects enzyme activity? Number 1 is temperature. Proteins change shape as temperatures change. Because so much of an enzyme's activity is based on its shape, the temperature changes can mess up the process and the enzyme will not work. Number 2, activators. Sometimes you need an enzyme to work faster and your body creates an activator. Other times you might eat something that acts as an activator. Activations make enzymes work harder and faster. If you're running a race and you need more energy, get those enzymes to work. Number 3, pH levels. In the same way that temperature can change the shape of proteins, the acidity of the environment does the same thing. Remember that the pH is the measure of how acidic or basic something is. So in your stomach, you have stomach acids, which have a pH of about 2.5. Those stomach acids will not work anywhere else in the body. Once they're out of the stomach, they're done. They don't work anymore. Inhibitors. Inhibitors are the opposite of activators. Inhibitors either slow down or stop the activity of an enzyme. They often bond to the protein and the shape changes. Remember, when the shape changes, the enzyme will not work the same way. A nasty example of inhibitor is snake venom or maybe even nerve gas from World War I. What you guys are going to do is you're going to go back into the article And there are 9 questions that you're going to answer. All of the information for those is right here in the article. We're going to move down to this graph. It says read the graph and answer the questions in complete sentences. Make sure you use a complete sentence. So for example, this one says, what is the optimal pH for pepsin? Here's our information for pepsin. So you would say the optimal pH for pepsin is, and tell me it. On this one, it says look at the picture and answer the questions in complete sentences. So this one says which molecule would most likely react to the enzyme on the left. You would say shape blank would most likely react to the enzyme on the left.